So today we're going to see about the GSM. GSM is nothing but a global system for mobile communication. So it is a standard which used in mobile communication. We will see in detail about what are the architecture, what are the components, and their working properties. The first is introduction. So the GSM is globally accepted standard for digital cellular communication. So it is used in mobile communication. It is the first standard which used in digital communication. So now also we are using it. So the standard is nothing but it's a set of rules. So everybody needs to follow. Then only we can able to make the communication throughout the world. If different person or different mobile company or different service provider, they are following the different set of rules or different standards, so we can't able to make the proper communication. So in order to make it proper, so everybody needs to follow some set of formats and some set of rules for their equipment or for the communication standard. So GSM is one of the best standard they are using globally. So in GSM, they are using the narrow band time division multiple access. What is narrow band? So we already seen something about the narrow band and broadband. We already studied. So narrow band, okay. It forwards the data to the particular bandwidth range. So in broadband, it's like a broadcasting. It emit the signal all over the area outside the bandwidth range also. So here we are using the narrowband time division multiple access. We in previous classes we studied about space division, frequency division, and time division. So anybody can say what is time division multiple access? Yes, the time division multiple access is nothing but they allocate some time for each user. So they using the same frequency, they divide like one. For example, if they have the 4 user is there, then they divide the time slot into 4, and they allocated each time slot to each user, like to 1 to 2 minutes for one user and 2 to 4 minutes for one user. Like this, they will assign so time slot to each user. Sorry. So here they are providing the voice and text-based services. So in GSM, and why GSM is required? Why we are using the GSM standards globally? So that is a major question. So these are the points which highlights GSM. So first one is the improved spectrum efficiency. We already know here the spectrum efficiency is high when compared to other, and it supports the international roaming. That means any person can speak to any person throughout the world. So throughout the geographical region, we can speak with any person. So the third point is the low cost mobile set and base station. That means the equipment which is used to build the mobile station and the base station and the equipment overall things are very low cost when compared to previous version. So and high quality speeches, because here using the high bandwidth and they are using the improved spectrum efficiency. So by default, the quality of the speech will be very high. So it entirely reduces the noises of the noises which added in the data or in the voices in previous standards or the previous mechanisms. So here, and then the last one is a compatibility. So compatibility with integrated service digital network, that is the ISDN, and other telephone companies. So it is like it can able to support with the mobile, can able to support with the PSDN and ISDN and other telephone companies also. It can support broader range of services, digital services network companies, and it support the new services also. We can able to add the new services as go on. And here we're going to see about the main components, major components which is reside in GSM architecture. So we already know what is GSM. it is like a standards. It's a set of rules which used in mobile communication. It's like we can call it as a digital communication. So the major four components is first one is a mobile station, and the second component is a base station subsystem, and third is a network switching subsystem, and the fourth one operation support subsystem. We see details and some of the additional components which is inside in each of these um, major components, like a subsystem, sub components. We'll see the other additional components of which is in GSM architecture. There is a home location register, and in this home location register is like a database which will store all the user information. So like when we are purchasing the SIM card, it will store our personal information, like our names and our the area and all other mobile device number and what are the services we enabled, so and everything. And the visitor location register, so it is also one of the databases, but it is a temporary database. So home location register is a permanent database because once we purchase a SIM, our information will be permanently stored in the home location register. So visitor location register is like a temporary database which stores our data for a particular time. So here, the requirement of visitor location register means, so when we are moving from one tower to another tower, so like one base station to another base station, so the we need to identify the current location of a particular user. So we already studied about in introduction section itself, so how the data are stored and how it will identify the user. So likewise, in a base station, in a home location register, we need to update the user current location. So in order to update the current location, it will keep track of the particular person location. So it will store their subscription details and all their personal details with their current location. So when they are moving from one base station to another base station, so it will update to the home base station about their current location. So if they are moving from one location, their home base station to other base station, then we can call it as a foreign home station or foreign agent. Sometimes we can call it as a foreign agent. That means that outside of your home location. Then at the time, the foreign base station will create some databases or store your information. That information is temporary information. Until you are in the particular region, the information will be stored. If you are moving to another location, it will be erased, and the other base station will create another temporary databases to store your current location in order to update your current location to your base station, your home base station. So these are the information will be stored in the visitor location register and equipment identity register. We already know when we are purchasing a mobile, so IMEI number will be there. So it is a permanent number. It is available in your devices. So it will match up when you are making a call. It contains some key values. So at the same time, the data itself, it contains some key value. It matches with the both the key value. If it is true, that means the both are the same, then it will approve to make a call or it will forward the call. So otherwise it will decline it. So the matches can be with your mobile number and your IME number, whether for security reasons. So on the last one is authentication center. So in authentication center, so it kind of three authentication is there. So you might know in hacker, so there are three types of hackers there. So anyone can name what are the three type of hackers? White hat, red hat, gray. Okay. Likewise, in authentication center, they categorize into three: the white, gray, and black. Okay. White is nothing but is a normal user. So when they here also it's like a databases. They will contain some set of numbers. So they will the white means they will it's a normal user. So when they're receiving the call from the white list, they will forward the call in a normal way. When it is a gray user, or it is like they are actually permitting, but their subscription date is expired. So when you are subscribing something like they are subscribed for 1 month, so but the date is extended, that means it is expired, then they move our data into the gray list. So in a block list, so if they want to block some of the numbers are some of the unused mobile number or unused thing. For example, if you are giving they complying to the police station like you lost your mobile, so you will give your IME number. So here in a block list, they will make your IME number, they will keep your IME number. So when they find, so the call is coming from the particular, the block listed IME number, then they will report back to the police station. So here the block list to block the particular user to making or accessing the services. So and then the last one is a SMS servicing center. So here they are keeping the two type of services. One is the voice services and SMS services. So when we are making the voice call, it will forward it to the MSC, that is a mobile switching center. We'll see in detail. So mobile switching center. When we are texting something, so it will be forwarded to the MSC, that is a message servicing center. So the last one is a gateway MSC. So if you want to make connection with MSC, between the MSC to MSC, then we have to go through the gateway MSC. So it is like a central control to it connects multiple MSCs. And chargeback center, it will help us to forward the data, and the transcoder and adoption unit, so it's like encryption decryption, so it will encrypt the data, and at the receiver side it helps us to decrypt the data. So it is used for encryption and decryption, mainly for security reasons. So here it's a mobile station. So mobile station is nothing but any wireless devices, or we can call it as a wireless terminals. So it's like a normal mobile is also called as a mobile station. So mobile equipment, we can call it as a mobile station. So it must be binded with a SIM card. So then only we can able to make a call, right? So it's a combination of mobile and the SIM card. So usually we'll call it as a mobile. Mobile, we can call it as a mobile station. So before we see the architecture, we have to know what it is. Then only we can able to understand their complete process and their process. The next one is a base transceiver station. So what is transceiver? What is transceiver? Okay, transceiver is nothing but transmitter plus receiver. So transmitter is used to transfer the data, and receiver is used to receive the data. So the transceiver means it can able to transfer and can able to receive the data. Then we can call it as the transceiver. So it's a base station. So base station, transceiver or base transceiver station, we can call it as a both. So here is nothing but a tower. So we already seen many towers nearby our location, nearby our home, right? So that is called as a BTS, that is a base transceiver station. So it is mainly used to receive the radio frequency and help us to transfer the data from BTS to our BSC. So we'll see what is BSC, and it helps us to directly contact with the mobile station. And then base station controller. So base station is controlled as nothing but it controls the group of BTS. That means it controls the group of tower in a particular region. So I'll give you some additional details when we get into the architecture. So, and then it communicates using the ABS interface. So, okay, we'll see in detail about all the interfaces between each of the components in detail. So it helps us to control the group of BTS. So that's enough up to now. So, and then mobile service switching center. Otherwise, we can call it as a mobile switching center. So mobile switching center, it's a core network. So it is a core or the brain of the entire process. So it controls overall process of the mobile communication. That's why we're calling the MSC as a core network area. Uh, Here, the inclusion is that registration, authentication, call location, and enter MSC handover and call routing to the mobile subscribers. So entire main process is handled in MSC. That is a mobile service switching center. Sorry. Okay. Here. Now we already studied about each component and their process. Here we're going to see the entire process in a single diagram. So as you can see, so first one is a mobile station. So it can be a mobile or any wireless terminal. We can call it as a mobile station. So we are taking the mobile and we are making the call. The call first reaches to the nearer cell tower. The cell tower, it call it as a BTS. So it receive. So BTS nothing but base transceiver station. So transceiver, that means it can receive. So it first receiving our radio frequency signal from our mobile terminal and it forwards that radio frequency signal to the MSC. So we already studied the MSC, it controls the multiple BTS. So within a smaller region, that means so multiple tower will be reside in a city. For example, if you take it as a any city, Suru or any other region. So in a particular city, not only the one tower, so it contains the multiple towers. So in order to control all the multiple tower, they have deployed the BSC. So base station controller. It controls all the handover activity and when to migrate the signal from one tower to another tower. So what is handover? Already I explained about the handover in previous classes. What is handover? Okay. The handover is nothing but when we are moving from one places to another, like one tower to another. We know the mobile station, it's mainly is a mobility. So mobility means it's like a roaming. So when we are moving from one location to another location, so one cell tower to another cell tower, based on their signal strength, so the call will be connected to the nearer cell tower. So if you are moving in the middle of the any cell tower, it will look for their signal strength from the both the cell tower. If which one is higher, it will connect the call to the particular nearer cell tower. That mechanism, that process is called handover. So here, so connecting the call or the making the entire call transmission process from one BTS to another BTS, though the entire process handover process, when to make and where to connect. So every process will be handled by the BSC. That is a base station controller. So here, after reaching from BTS to BSC, the BSC will forward it to the MSC. It's a mobile switching center, otherwise we can call it a mobile service switching center. So here, it contains the multiple sub-components. So let's see one by one. So HLR, So as I said, is a home location register. So when we are purchasing the mobile SIM, here our entire information and our subscription details and our current location information will be stored here in a HLR. So VLR is nothing but visitor location register. So when we are moving to foreign mobile station, sorry, foreign MSC. So here is a home MSC. So when we are moving from our home MSC to another foreign MSC, that means other than the home MSC, we can all the other MSC, we can call it as a foreign MSC. So when we are moving from home MSC to foreign MSC, so that time the user data will be stored in temporary manner. That temporary data will store in a VLR, that is a visitor location register. That means the user current location will be temporarily stored in the VLR, and that information will be forwarded to the home MSC. Okay, VLR and authentication. So it helps us to authenticate the user, whether to allow the user to make a call or decline it. So those authentication process will be handled in the authentication. So and then the operation support subsystem. In below we see the OMC, that is a operation subsystem. So we can otherwise we can call it as a operation management system. That means that so if fault or any of the technical failures is happens at the MSC will be handled using the OMC. Okay, any the device equipment failures are handled by the OMC. So so after reaching the call from MSC to BSC, so BSC first forward to this information to the HLR to see whether the user belongs to our home location. So if the information is available, so then it looks for their current location and their the subscription details, and it will forward. So if it is okay, then it will forward the data to the authentication. The here authentication is on the Mac and all their subscription, whether it is expired or not, and how long they can able to make a call. So whether they are living, they're roaming for the particular customer, or so like this, they look for the all the authentication process. So if it is verified, then it will acknowledge to the MSC. Then MSC will forward the call to the appropriate the cell tower, because we already studied the home location itself. So if it is a home user, it will keep on tracking the current location. Based on their current location, it will forward it to the nearby BTS. So sorry, BSS, from the BSC, the BSC will forward it to the BTS, the BTS to the other, the destination mobile station. So if their information is not present in the HLR, so then it will look for the VLR database. So if it is not the home user, then it might be it must be the foreign user. So it will look for the VLR. So the VLR, after the VLR, if it is found the user, it's a not belongs to the home MSC, then it will send the information to the MSC. The MSC will forward, the foreign MSC will forward those information to the home MSC of a particular user. So from the home MSC, after the home MSC, they look for their HLR and their authentication. So after all the authentication process is completed, it will send the acknowledgement to the MSC. Then it will make transfer or forward the call to the destination process. These are the entire GSM architecture. So other these things, PSTN and ISDN and data network is another kind of the networking, like the LAN and different kind of the telecommunication technologies. So the GSM supports all the PSTN, ISDN and data network. So the PSTN is a telephone and everything is a public network. So you can able to integrate with other kind of network technology. So these are the entire architecture. So it's nothing but first when you are dialing the number, the MSC will forward or call to the BDS. From the BDS, so it will forward to BSC. The BSC will handle all the handover and all the process, all the data receiver and forwarding the data. So after the BSC will forward the data to the MSC. So if it is the home MSC, then it will look for the first, it will look for the HLR. If it is belongs to the particular home MSC, it will authenticate the user. After that, the call will be forwarded to the particular destination. So if it is not the, if he is not belong to the home MSC, then it will look for VLR. The VLR information, it will find out where the actual user belongs to. Then it will forward it to the user's home MSC. From the home MSC, the process that is the same process for HLR. From HLR, after that, it will authenticate the user and forward. So if it is not authenticated, it will decline. So already said based on their subscription or the number, if it is the number is not registered, if the subscription is invalid or expired, so they will block the call. So if they have passed all these authentication, then it will forward it to the destination. These are the entire process or entire working the communication process. So if you have any doubts, you can ask. Okay, thank you.